Hello everybody. The topic on which I want to talk in this video is actually regions of the electromagnetic spectrum. An electromagnetic wave can actually be propagating along some axis called k-axis, and when it is going like that, then it will have the electric field E in some axis that's normal to the k axis, and then normal to both E and k axis will have the B axis. B is actually for the magnetic field and E is for the electric field which the electromagnetic wave is carrying with it. And when it is doing so, we can define the wavelength as a length of the perfect kind of wave, one wave of that electromagnetic radiation is propagating like this. So if we define the lambda like this, then we can obtain where lambda is the wavelength of this electromagnetic wave, and from this we can obtain the frequency of that wave with the help of this equation, where c is actually the velocity of light in vacuum, which is 3 times 10 power 8 meter per second. And having defined lambda and c through these this graph and this this figure and this equation, we can now divide the regions of electromagnetic spectrum into 6 regions: 1 2 3 4 5 and 6. The first one of these one is actually radio frequency region, in which the frequency of the electromagnetic wave will be actually between 3 into 10 power 8 hertz and 3 into 10 power 10 hertz. And the wavelength of that light, radiation, will be actually from 1 centimeter to 10 meters. And the energy of the photon of this energy of photon of the radiation of this region is actually of the order of the changes of energy which are involved in spin of nucleus or maybe spin of an electron. So we can use this radiation to study nuclear magnetic resonance spectroscopy or maybe electron spin resonance spectroscopy. This is about the first region of electromagnetic waves. And second region could be actually microwave region of electromagnetic spectrum. In this the frequency of the electromagnetic waves will be actually between 3 into 10 power 10 hertz and 3 into 10 power 12 hertz. And the wavelength of the electromagnetic waves will be actually between 100 micrometers and 1 centimeter. And the energy of the photons of this region will be actually of the order of the change of energy of some molecule because of its rotations. And this region of the radiation can be used to actually study the rotational spectroscopy of molecules. And then the third region of electromagnetic waves can be actually infrared region, in which the frequency of the waves will be actually between 3 into 10 power 12 hertz and 3 into 10 power 14 hertz. And the wavelength of these waves will be actually between 1 micrometer and 100 micrometer. And energy of the photons of this region will be actually of the order of change of energy of a molecule because of its vibrations. And this radiation can be used to actually study the vibration spectroscopy. So this is it in this infrared region. And the next region is actually visible and UV region of electromagnetic waves. And in this the frequency of the waves will be actually between 3 into 10 power 14 hertz and 3 into 10 power 16 hertz. And the wavelength of these waves will be actually between 10 nanometers and 1 micrometer. And the the energy of the photons of this region will be of the order of change of energy of an atom because of its electronic levels. and these photons are used actually to study I mean electronic spectroscopy of atoms. And the fifth region of electromagnetic waves, we can actually say X-ray region, in which the frequency of the light photons of this region will be actually between 3 into 10 power 16 hertz and 3 into 10 power 18 hertz, and the wavelength of these waves will be actually between 100 picometers and 10 nanometers, and the energy of photons of this region will be of the order of change of energy of an atom that happens because of inner core electrons rearrangement. And it is used to study, this radiation of this region can be used to study in X-ray imaging. We can use them to image things to obtain an X-ray image. So anyways, the last region is actually gamma ray region, in which the frequency of the electromagnetic waves that belong to this region will be between 3 into 10 power 18 hertz and 3 into 10 power 20 hertz, and the wavelength of these waves will be actually between 1 picometer and 100 picometers, and the energy of the photons of this region will be of the order of change of energy that happens because of rearrangement of nuclear particles. And this radiation, the gamma radiation, is used in oncology to actually kill cancerous cells. So anyways, this is it I want to talk in this video, and I hope I made some useful points here for you, and I will meet you next time with some other video. Until then, bye bye.